All right, everyone, welcome. Good morning, good afternoon, and good evening. This is, let me hide this. This is our knowledge transfer for the semiconductor engineer role for the 24x FD04 and 25x GA releases. Basically, the content, the feature content for both releases is the same. And the big content that we're going to be discussing is something, it's a new web app in 3D Experience called the Semiconductor Design Environment Management app. And it really pulls together almost everything for the semiconductor engineer role. So that was going to be the, well, hopefully it will still be the primary focus of the discussion here this morning. And Peter Haynes, who's an R&D product define person, is going to be presenting that. Typically, we have the developers that have worked on the feature present, but there was almost every developer on our team was working on this design environment management application and the subsequent client-side functionality. So, and Peter's been doing a lot of flow testing, and so it was really great to have him step up and put together the material for seeing how it all comes together. So, and his, even though I outlined only 30 minutes, it'll be more like an hour for him to go through his presentation. And that's just an overview, okay? Not next week, but the week following, the first week of December, we're going to have a session of deep dives that goes into this design environment management functionality in much more detail. There's going to be at least 3 1.5-hour sessions, and I'm not planning on sending that out as an email invite in Outlook. I'm going to post the meeting information up on the XCC swim community. And if you're able to attend, great. Just go to the community, look for that post, and join. But we'll record not only this session today and post it to the community, but those deep dive sessions as well. We'll record those, and so you'll be able to really have that for background and reference going forward. Okay. But while we wait for Peter, let me go ahead and here was the meeting invite, and this is where I'm mentioning the semi-design management or design environment management topic for Peter. But we also had one other feature, not quite as major, but it basically was an add-on to a feature that we rolled out early in 24x, I think it was FD01, where we introduced a client-side command where you could take, if you had existing semi-data being managed by Design Sync, you could at least start creating the semiconductor logical item structure up in 3D Experience and have all the different revisions of a semi-logical item that refers to a Design Sync module. But that's all we did was we created semi-logical items. We did not transfer any of the data out of Design Sync and check it into the semiconductor repository in 3D Experience. Well, in this 25x GA release, we have extended that flow so that you can basically tell the command that we provided earlier to go ahead and check out from Design Sync and whatever version of the module that the data is in, it will get checked out to a temporary workspace, and then it will be checked into the semiconductor repository up in 3D Experience. So that's a quick summary, but let Mahesh go ahead and show a couple of slides. This is going to be pretty quick, and then we'll hopefully get back over to Peter when Mahesh is finished.
Ron, I was able to get that back on, but I need to start up again.
Okay.
Can you go ahead and do yours now, and I'll get all this stuff?
Yeah. Well, we're going to go ahead and have Mahesh do his first.
Great, thank you.
All right. Yep. All right, Mahesh, you want to share?
Yeah, now that I'm feeling great that I'm the fill-in act. So,
You're the fill-in act.
exactly. I'm going to take over the share and hopefully share the correct.
Opening act.
Opening. Yeah, there you go.
The warm-up band.
All right. So if you're seeing a slide, then I am on the right screen.
Yep, we're there.
Right. Yeah. So there is an announcement that was made.
Mahesh, can you go to full screen? So, but
Oh yeah.
thank you.
Did I do that right? No.
No, it's the other one. Switch. Go up to your display settings. There you go, Mahesh. You got it.
Yeah. So, but it's still not full screen, right?
No, you'll have to go down to the bottom right of PowerPoint right there. Yep.
Oh, right here, this one.
Yep. You got
That's
it.
what I thought I did earlier, and it shows this.
Oh, yeah. Well, go up to your display settings, Mahesh. Pull down and say swap. There you go. Thank you. That's it.
So the migrate command already existed before, and as Ron said, what it did was it let you migrate to what would be called an external design sync connector, meaning that you've got a design sync module which has got a number of branches and maybe tagged versions. You could run the migrate command, which would create a semiconductor logical item revision corresponding to every tag that you ask to migrate, which means you get the tree, the revision tree in that sense. But each of those semiconductor logical item revisions would be connected via the external connector back to the original design sync version that it came from, meaning the data never got migrated into the semiconductor repository. Right, so you still needed to have your design sync server around. You still needed to have all of those modules lying around because it'll still be referred to in those semiconductor logical item revisions. So the extension was not just bring in those semiconductor logical item revisions, but also migrate the vault information, which would basically mean you fetch out the data from the from design sync module version and check it into the semiconductor repository. So at the end of it, you have all of the data migrated also. So to enable that, there are three new switches. So there's the dash dash repository switch, which is the Boolean switch that tells it which migration do you want. Do you want to migrate and still retain it as the external modules, or actually migrate also the repository data? So if you use the dash dash repository, it will migrate in the repository data as well automatically. The dash dash workspace switch is an optional switch, other will default to a temporary location that it uses. That's required when you use the dash dash repository because the migration is basically done by fetching out from design sync and checking into the semiconductor repository. So for that, it needs a temporary workspace that is large enough, which would really mean the size of the data that you are migrating. It uses the same workspace into which it actually populates from design sync and checks into the repository because they use the metadata in different ways, right? So you can actually do that in the same workspace. So it doesn't have to be two workspaces. So the amount of disk space that you need is just equal to the largest vault information that you have or the largest workspace that will be created. Verbose just changes the output verbosity. So now when we are doing the vault migration, remember in design sync supported symbolic links, semiconductor repository also supports symbolic links. So if you have got symbolic links that have been checked into design sync, they will get preserved exactly as is, no problem. If you have collections in design sync, so you have the cadence collections, you got a layout.sync.cds. The layout.sync.cds was kind of a meta object in design sync, which kept track of the actual files that belong to that collection. In the semiconductor repository world, we still work with cadence and synopsis, but we don't use that artifact of a collection notion being required. It's not needed in the semiconductor repository. So those objects simply don't migrate whatsoever. So you're not going to see anymore once you migrate. You still get all of the data. So if you actually migrate the data and then now you go and create your workspace from your semiconductor repository, you will be able to run the cadence plugin or a synopsis plugin of the semiconductor variety well, the Cadence plugin, without any issues. It's just that those artifacts don't need to be migrated, so those will not be migrated. They just migrate the individual files. The timestamps of the files will be retained. This is important only enough if you want to, when you fetch out the data, that it gets back that old timestamp, and that's fine. No key expansion. So it will be just do it in a non-expansion mode of the keys and check it in. And then this last bullet talks about that not every version is migrated, right? We only migrate the ones that you specified. That doesn't change. That's already the case today with the migrate command. You can specify the list of branches or tagged versions you want migrated with a -- tag switch. And there's even a -- tags file switch. So you can list those tags in a file and give it the file name, and it'll work off of that. So that remains the same. On each tag and branch, like we said, there'll be a semiconductor logical item revision created for each one. And the corresponding repository branch will hold the data. The name, the revision name on the SLI and the branch name on the same repository will be the same as the tag name. And only the delta changes are applied. So you actually get back a structure which looks exactly like the design sync vault, in that if you have, let us say, you're migrating version 1.5, which was tagged gold, and you're migrating 1.7, which was tagged silver, the two revisions will be created, gold and silver, on the semiconductor logical item. And when you're checking in the data, it only needs to check in the incremental data from 1.5 to 1.7. It's not as if each version is like a full version of all of the data. It's the same kind of deltas that design thing stores, right? You got your commits and you got your change set. So you've got only the delta changes that will be applied at each commit. The comments that are there from your design sync module are not carried over, but for every revision that we create, we capture a comment, and in that comment for the commit, we capture the design sync version number that it came from. So that's kind of useful if you ever want to go back and see that. You can even run, which I do as automated tests, just to run to see that things are working correctly. Fetch out actually the design sync version, and then the same corresponding version from the repo, and then diff the two to make sure that the migration worked correctly. So that's all I had in terms of the slides. Any questions?
So Mahesh, the workspace is temporary, right? You're not left with a working workspace.
Yes, the workspace is temporary. There is a -- debug switch, which I did not expand in here. Yeah, so the workspace gets deleted at the end. What you're specifying with the -- workspace path is just in case you need to specify a path where to hold large enough. But yes, it'll get deleted. There's a -- debug switch, which we use as part of development, that will retain the workspace. It's available for anyone to use also. You can retain the workspace after that, and you can examine the workspace too. But yes, under normal circumstances, it'll get deleted. So if there are no more questions, then I think we're done.
No,
Mahesh.
Mahesh, I have one question. What happens to the data in design sync?
The actual source from design sync?
It's left alone. It's just used for read-only purposes.
Right.
Okay, so but the data will be locked, or it will be I mean, will there be a way to know that this data has been moved to or has been migrated to
No. So this migration doesn't do anything whatsoever to the design sync module. It basically just reads from it, as Ron said. It just populates from it and then checks it into the repository, and does not change the design sync server in any way. So if we need something where you want to either freeze the module or set some access control, that will have to be done separately.
Okay, but that can be done after, right?
Yeah,
Sure.
I mean, there are design sync commands that you can send to freeze a module or lock a module or update some access control.
Okay, thank you.
And Mahesh, if you could go back to your first slide.
Yep.
If you want to understand in more depth, I suggest to go back to the previous knowledge transfer where the Swiss admin migrate command was first covered. And then you'll understand like the tag switch and how the revision tree structure of the semi-logical item maps to the tags or the versions that you're bringing over from design sync module. We're not going to go over all that again here, but that's been all covered before.
Okay, thank you, Ron.
Okay, no problem. With that, let's go ahead and switch over to Peter, who is up and running now. And we're going to get this is a very big set of functionality. So strap in and hold tight. All right, Peter, go ahead.
Okay, thank you very much. I'm sorry for the little delay there. So this is the knowledge transfer for semiconductor design environment management for 24x FD04 and 25x. Now, put it in perspective, semiconductor engineer, that term can be thought of as the replacement for design sync, if you will. On the platform, we find the semiconductor engineer role under the compass, and if we go to that role, we find two different applications. Semiconductor item management, that's the thing we've been working on for quite a while. That is essentially the revision control application, and that is where we have built the new semiconductor repository that you've heard about that replaces the design sync repository. So this is the control application, if you will. The semiconductor design environment management is this brand new app that is now being released, and that's specifically what we're going to talk about today. This will be an overview of just this app. The knowledge transfers tend to show some concepts and show you the look and feel of the applications. The week after, Ron may have covered this as I was trying to get my environment back, but the week after Thanksgiving, the first week in December, I'll be doing either 3 or 4 1.5-hour sessions on semiconductor overall and basically a deep dive in how all of this stuff fits together. So today we'll just take a look at the changes for this release. So the enhancements that were made in this release is in semiconductor item management, the revision control piece, there is a new piece in there called My Design Responsibilities, and you'll see what that is as we go along. But semiconductor design environment management is the entire new application, if you will. So I'll use some acronyms in this presentation. I do want to point out that these are collaboration tools for design teams that the design semiconductor tools themselves. Design is done by third-party tools, Cadence, Synopsys, in Unix environments on those systems. We're basically enabling very large design teams of sometimes hundreds of designers across dozens of design centers around the world to make sure that they all have a identical environment to work in. I'll use some acronyms. I'll use SIM for semiconductor item management. The primary object that it manages is called a semiconductor logical item. SDEM will be semiconductor design environment management, and its top level object is an environment, an SDE. So as I said, semiconductor enables collaboration, design formed on the platform, because they're designed using, as I said, these third-party automation tools on Linux machines that run on local area networks at physical design centers. And these EDA tools write design data to disks that are on the local area network. And the platform, this part of the compute infrastructure for our applications is basically on the client side, if you will. So our applications have command line interfaces that tie us over into that side. So our applications enable the design collaboration by ensuring that all designers are working with the right design data, the revision control part, using the same set of design tools, configured the same way across all of the geographically dispersed design centers. So in order to do those, these applications bridge the gap between the platform and the client-side applications. So I like to think that the semiconductor engineer connects the platform universe to the client side design environment, if you will. So I'll be doing a demo scenario here. And in this scenario, we have a company that builds their own technology. This would be a company like ST Micro, for instance. They build their own technology platform of the lowest level leaf cells that go into a semiconductor design. And then they have other teams that build IP blocks, or IP, if you will, based on that technology. And starting at the bottom, the technology, I'll call it a 90 nanometer technology that has a physical design kit. There's a standard cell library. There's some phase lock loop library that is built on that. So this technology, or this team, has built a technology that's managed in a semiconductor logical item. But in there are three different EDA libraries. These are the libraries that the EDA tools actually read and write to on disk. There is a team building an analog controller of people, and it has a single library in it, but that library instances things from these libraries here. So this design is based on technology. We have another team building a bias port design that's also based on that technology. And then the one we'll demo today will be a team called an Ether. This is a step-based chip, something you'd find or modem IP, something that would be found on a chip in a fax machine. It has one EDA library called Ether. It's also based on the same technology, but it instances these two other designs which are on that technology. So the design reuse is fundamental to semiconductor design because nobody built it. It's all built of pieces that already exist. So if we look at it a different way, the legend here is this is a semiconductor logical item, as is this. And this instance is something that makes a dependency between the two. Our lowest level design team has a semiconductor logical item that is going to do data management for the technology itself, and they have released that. This analog team has built theirs based on this technology, but they've released their design as well. This bias port has two versions of their design here. And the design we're working on for this demo is this Ether team, and its structure, if you will, looks like this. They use this technology, they use this analog control, which also uses that tech, and they use this bias port, which also uses that. You might note that there is a potential for conflict in this structure if one of these IP was using a different version, maybe R2 or R3 of this technology. That would be a problem. But our tool will handle that on the client side. To build a workspace for this design, it will say, I can't put two versions of the same thing design, and then I'll build you a workspace. But if we were to go into semiconductor item management and look at this design and look at the structure of the design, this allows me to look at the content of what's in the repository. This is the structure of the design, and for the design sync users, this is the analogous of hierarchical references. So here, the Ether has used this technology, but it's also used these other two IPs based on the same technology, and they're all managed by different teams of different people. So I'm going to start with a couple of key concepts here. The first is that of a design environment. So when designers are collaborating on a design using EDA tools, running on networked Linux computers at some design center, it's not only important that everybody's working on the same design data, but that they also be working with the same version of the same EDA tools that have been configured the same way for use on the design. So there's a lot of moving parts in getting everybody working in exactly the same compute environment, as well as using exactly the same data, which is what the revision control part does. So the EDA tools themselves are installed on a network file system such the executables can be invoked from any machine on the network. So for those maybe not familiar with Unix or Linux, Unlike Windows, which is essentially the operating system for the business world, where we install software on every Windows machine, in a Unix system, that is a multi-user system that they work on machines on a network, and there the software is not installed on every machine. It is installed somewhere on a disk where the executables for that software can be seen from any machine in there. This is all handled by the CAD computer-aided design groups that set all this stuff up. So the tools themselves in most cases are already installed at each design center, and we're going to be connecting into those. And there's many tools involved in a flow, such as authoring tools, such as Cadence Virtuoso or Synopsys Custom Designer, used primarily for analog design or design at the transistor level. There are automated place and route tools for design at more of a digital design level, a higher level of abstraction. There are simulation tools of all kinds, transistor level, logic level, mixed signal designs, what have you. There are verification tools that basically determine does the design behave as it was intended, and is it fault tolerant of say, manufacturing faults? Can you detect those with your test patterns? And validation tools, so that if make sure your physical design matches the design that you simulated up in these other levels of abstraction. There have been, I've heard companies having upwards of 100 design tools in a design flow. So everything I'm showing here in the real world is amplified by many, many times over. And some of these tools configuration for use on a design. And one is an example is enabling the integration with a revision control system. And for instance, we have integrated semiconductor engineer commands into Synopsys Virtuoso or Cadence Virtuoso and Synopsys. We're working on that, but they're integrated in there so users can do their revision control using our collaboration tools, but one sitting inside of a tool that's running in a network somewhere in a design center. So these tools just don't do that by magic. Somebody has to set this stuff up. Now, the set of tools used here are all controlled in a Unix environment using things called environment variables. I'm going to not say much more about this because we're going to go into great detail about this in the deep design the first week in Texas, but there are scripts and such that set all this stuff up. It takes a lot of expertise to get everything up and running in one design center. The whole idea here is that rather than now having to have that expertise at every design center, you could have dozens of them, getting everything up and running for the people working there. What we will do is we will take all of that knowledge, if you will, of how to set everything up. And rather than having it set external to designer workspaces where they're working on each network, we're going to actually capture that into each workspace. So once we get something up and running on one network, when we make a design workspace or a design personal copy at any design center, it will in fact subsume or pull in the entire design environment to that workspace. So everything works everywhere, having been set up on the platform once. Semiconductor design environment management is the new tool that's ensured to make sure all of this stuff works. That's what we'll be talking about today. So another concept I want to get put is the idea of a design responsibility. There's many different designers on a design team that do different things. Some people design, some people verify, some people do schematic capture, some people do layout, some people do place and route. All different people doing all different types of tasks on a single design. Okay, but when working using the legacy tools, DesignSync, our DesignSync Enterprise Administration, which was the legacy of this DesignSync environment or the app we're talking about right now, or Semiconductor Engineers Semiconductor Item Management, which is the next gen revision control tool. If you're using any one of those things, a user essentially self-assigns to work on a design. Okay, well, what does that mean? It means They do this by knowing what they want to work on, how to find it, and then going and creating a design area, which is basically their own personal copy of design to work on it. There's a lot of knowledge that goes into actually knowing how to do any of this stuff. But when they actually build their own copy of the design, what goes into their design area is all controlled by the server-side access controls for the revision control system. When you're using our new application, SDEM, or Semiconductor Design Environment Management, a design leader assigns a responsibility to a user. So the user, their starting point is just, what are my responsibilities? And they're going to now create a design area or their personal place to work for the responsibility itself. So they don't need to know where the data is, what the name of it is, how to find it. All they need to know is find out what they've been assigned to do. So when you put these two things together, in addition to the server access controls for the data that can be pulled into a workspace, if you will, or a design area, we're now also controlling access to the creation of these design areas. People can actually go work on these things. Now, the creation of responsibility is specifically tailored to an activity, as I was mentioning. And as an example, I already mentioned that designers doing tasks use different design tools. And to demonstrate some of this flexibility afforded in this demo scenario, the designers of my Ether modem design team, they're going to be using Cadence Virtuoso with semiconductor engineers commands integrated into it. So they can lock and modify and check in data from inside those tools. These are the designers that have read and write access into the repository for that design. The verification engineers in here, they just verify that things are right. They don't actually have they don't have write access to design data. They create a bunch of new data, but it's unmanaged, doesn't have to get checked in using their design tools, but they don't actually change the data in the design itself. So I'm going to have those designers using Synopsys Custom Designer instead. Well, today, Custom Designer doesn't actually have semiconductor engineers command embedded in it. It's coming soon, so you could do that, but it's just a way of showing that depending on who you are, when you build a design area for responsibility and you go to work in it, there will be a different design environment of different tools there for you to work in. So in the scenario that we're going to talk about here, there's actually 3 applications used. When we talk about access controls to either the data that's in a repository or the right to create a design area to work on data that's in a repository, all of that's done by assigning user groups. And user groups is a application on the platform that just collects together user names, platform user names. I will be doing this demo on an E4all, which is a on-premise server installation. On-premise, user groups are not a web app that can be dropped into a dashboard, but rather they're part of another monolithic application called collaboration and approvals. If I was doing this on a cloud instance, rather than collaboration and approvals, I would be using just a web app called user groups as well, but they do the same thing. Our applications are these two here, as I've mentioned. This is the brand new one. This does data management, revision control, structure. That's the IP reuse, connecting things together. And this is where we put these my responsibilities into there. This is the new app. This is what automates the creation of a design area in which the design environment is self-contained for a responsibility for which your user has been assigned. Okay, now semiconductor item management, the design data management side, which is this guy, and the other one is this one, icons on the platform. They each have command line interfaces on the client side. The design data management interface is called SWS, or semiconductor workspace. This is where we can lock data, check in data, compare data. We do all the revision control stuff there. Design environment management is something that allows us to not only fetch data, but fetch data in the context of an environment. All the tools run the same at every environment. Notice that both of these command line interfaces have a create command. But if I created a design, I'll call it a workspace, for a semiconductor logical item connected to a repository, I would end up with a directory on the client side that had just the design data in it. If I was to run SDE create for a responsibility, the responsibility has attached to it a top level semiconductor item that ties it into design data. But when I create a design area, I will fetch not only all of the design from all of the repositories associated with the individual IPs, but I'll also get the entire design environment as well, so I can run tools, and they're the same at every environment. So creating, I'm differentiating between a workspace, which is just managed data, and a design area, which is basically an area where you have all of the managed data, but you also have all of the compute environment that is necessary to support those workspaces. We'll go into this in a lot of other detail the first week in December. For instance, if you build a workspace using this, you will just get copies of the files. If you do it over here, you're going to do it in an environment that has automatically set up caching or file sharing, so that we efficiently make a bunch of workspaces, but all sharing the same read-only data in caches. All of that is built under the hood to this environment thing, because caching is not part of data management. It's just how you efficiently share data on the client side. So what do each one of these applications do? User groups just group names of people together. The semiconductor item management, its primary object, business object, is a logical item. That's what represents a design IP, if you will, a managed data set. It has a URL, and if I ran an FWS create on that URL, told it where I wanted to put on the client side, I would get the design data. This also has the semiconductor repositories we've been working on for several years now, and controls access to who can read and write data in these repositories. This also manages the structure or instances between them. For the design people, those would be hierarchical references between modules. And the new thing here is this my responsibilities, which for a regular designer is the only thing they would ever have to even look at. Just go here, pick one, create a design area, and then it'll keep track of what they made there. This is the whole new thing. And this allows methodologists that set up design flows to get everything up and working, and then project leaders to set up design teams of their people to work. So they manage some objects as well. One is called a design tool suite. That basically captures paths to software tool installations that are pre-installed at design centers. For instance, if you thought of Design Sync as a design tool suite, there's a path to a bin directory somewhere in that installation that has executables, which are actual design tools, and the executables for Design Sync that could run out of that tool suite at that design center would include DSSC command line, STCLC command line, DesSync GUI, Sync admin tool, and so on and so forth. So this tells you where the executables are, and this tells you what the individual ones are. These are not set up by project leaders. They're set up by people that design flows, if you will. A project leader would start with a semiconductor design environment for his particular project. Our project's going to be this Ether modem team. So when we set that up, we're going to give it a name. Then we're going to tell it what is the top level item. Another, what design do you want to fetch into the area? And if that item has structure, it'll get all of them into an area. We're also going to tell it ahead of time, where do we want to put this thing? Because in general, how companies organize where all of this work gets done on disk is not in people's home directories. It's where it's been set up to work for them. So this will capture, where do you want all of these areas when people start creating them? This design cache passes, where do you want to locate the shared area that makes all of this data highly efficient as far as disk space usage is on the client side. And once we have put that together, then we're going to create one or more design responsibilities. The design responsibility is going to have members, and that's going to determine, who could create a design area. And what are the design tool suites that you could invoke from that area? So if Design Sync was one of them, you'd have a design tool suite called Design Sync. And if they wanted to go run something, they could pick all those other tools from that. Down here is, once people actually have made things, it will start capturing where all of this data went down in the client side back in these areas. So these things here are just information that's displayed. Once all of this stuff is set up.
Hey, Peter, quick question.
Yes, absolutely.
Real quick, the tools themselves,
Yes.
if we're talking about distributed design sites, is it possible to configure it where the tools don't have to live in the same path in each one of the different sites? Do you have that level of flexibility, or how does that work?
Absolutely. I will come, I'll mention it when we get to that.
Okay, great.
But I will say that we have configured this thing such that basically two things I expect companies to find is that when you go to each design center, you'll find that the topologies of their local area networks are usually not the same. It's very unusual for every computer network to look identically at every design center, unless the company grew organically as a whole. Companies grow as a matter of acquisitions, and they inherit all the design centers. So that at one designer, they want to put all these workspaces for the Ether design under /projects. But in another one, they're going to put it under designs. And so that is something that we will set up using a variable. We set it each design center once. And then when we tell it to go do something, it says, at this center, you go put it there. And the other thing is, it's unlikely that the design tools themselves have been installed in the same paths on the networks. So we have another variable that says where to go find those things. I'll cover all the excruciating detail of all of that
Right,
first week
you.
in December, but I'll just point it out when I show you some variables today. But
Peter,
yeah.
maybe before you go too much further, any other questions? Let Peter get a drink and
Thank you. That's what I was doing.
So yeah. Anybody else with just maybe questions about concepts, because that's a lot about what's been talked about so far. Okay, well, as Peter goes through it, hopefully these things will start, when you see it in action, right? Then it'll start becoming clearer as to how it fits together even better. So
absolutely.
Please continue, Peter.
So I'm going to do a demo here. I've already set up, by the way, these environments for all of the design teams. Remember, we have already released the technology platform. We've released the two IPs, the analog controlled bias port. Those have all been released, but they were all set up using the same thing. But now we're going to start from scratch with a project leader that's going to build an environment for people that are going to work on this Ether design. And once he's done it, any user at any design center can simply say, create me a design area for my responsibility, and everything will magically work at that point. I'm going to quickly show you on this slide. I've captured in the following slides everything I'm going to do here, but I'm going to do it instead. When you come back to either look at this, or if you look at the PowerPoint, I will give you a slide for each one on each individual thing I did here, but I'll show you that live. On this slide, we're using three different applications that are color-coded here. And we've got to do things, we're going to set things up in the area that, in a way that makes sense. And remember, this is all done by one guy, the project leader. And once he does it, this stuff will all work at any design center for anywhere. And we don't need computer-aided design expertise at all the design centers to make this stuff work, just one. So the first thing we're going to do is create some groups as to who is the lead of the design. I'm going to be the lead. Who are the designers on the design, the people that have read-write access into the repository, and who are my verification engineers, the people that can build design areas. If they get all the data, they can do all the verification, but they couldn't check in changes to the repository, so they have a write access to the repository. So we've just
I mean,
put
they
this,
have a read access.
they have a
to the
read
repository.
access only to the repository. So remember, the design team's going to be huge. The design team's going to have hundreds of designers across dozens of design centers, but we set this level of access up first. Step two is we're going to come and create a semiconductor logical item, because that's our primary platform item for this thing that will represent the work of this design. And that's the item, by the way, that ties into the rest of the 3D experience universe. This is the design, but we could also associate with that its requirements. And we could use project management to manage the design. We could do test of what all the other universe can be tied to this item itself. But we're into data, the design data management primarily on the client side. So when I create this logical item here, it's going to create for me a repository. A semiconductor repository is a service on the platform. It's like GitHub, if you will. But it creates a repository, and in using semiconductor item management, this app, I'm going to go in and set up repository sharing, and I'm going to tell that the leader of this is this person in this group. That's myself. Contributors are my designers, and and the viewer access in here is a read-only access. Well, my verification engineers are going to be part of that group. But there's another group here called design, because this is going to be an IP that could be used in other designs. Well, if this is dropped into another design, it can't end up in somebody's workspace unless they have read access to this repository. So this is a group of designers, of all the designers that might want to read, so that allows anybody to get read-only copies in their workspaces. Then I'm going to connect together with instances all of the other IPs that this uses. This is my technology, this is my bias port, this is my analog control. Each one of these things is now going to have this group associated with it. So these people can read all of these things into their workspaces. But this is the design data management part of it stuff. Then I'm going to set up a responsibility, and I'm going to call it design. So now we're in design environment management. In there, I'm going to say what members can create a design area.
Peter, you missed steps 5 and 6.
Oh, yes, I did. Sorry.
No problem.
I'm just so excited. So we've set up our item. Now we're going to set up an environment in which to work on that item. So I like to name them the same, make them the same revision, because if I make a new revision of this, I'm going to make a new environment for it to keep all of these things nice and separated. Now, this item here, the first thing I'm going to do there is tell it, well, what is the data that would be fetched into this design? Well, it's this item. So that's what does the design management part. Then I'm going to create a responsibility. Thank you, Ron. This I'm going to call design. I'm going to assign some members in there who can create a workspace. These are all my designers, but because I'm the design lead, whenever I create anything, I add myself to that same group so I can test it, make sure that it works. Those people doing design are going to be using Cadence, and they're going to be able to use some shells, which I'll show you on the client side as well. There's another piece here called reference data. That is another semiconductor logical item with some scripts and other things in it that configure and set up design tools at design environments. That is where we get into the deep dive the week after Christmas. I'm not going to talk about this level at all, but suffice it to say the magic happens because this data is in the workspace along with this data. That's what we mean by bringing in a lot of ways, what we mean by bringing the environment in. And we create another responsible called verification. They're going to have a different set of users for verifying it myself so I can test it, but they're going to be using Synopsys, not Cadence. We can do different things. So that's the steps we're going to do. So at that point, I'm going to get out of this.
Now you're going to see that it's real.
Yeah. But why won't this Cadence? Why won't this stop? Why can't I get out of?
All your dreams will come true.
Yeah.
Only if he can get out of PowerPoint.
Why can't I get out of PowerPoint? I'm hitting escape and nothing's happening.
Don't know.
Just the escape button doesn't work?
It's just doing nothing. I've never seen this before.
Right click on your PowerPoint and end the slideshow, Peter.
Then click on your taskbar down below.
End show. Ah,
There you go.
there we go. Thank you. Okay, so I have 3 users here. This is me. I am now logged in here as myself. I'm using 2 applications here. I'm over here. I have collaboration and approvals because I'm managing user groups and I'm doing it down in here. And these are the user groups. If I was doing this in on the cloud, over here, I have a dashboard that's set up that this tab has semiconductor item management. This has design management in it. When I do this on the cloud, my first dashboard item here is groups, and I do it all right here. It's kind of nice. But the groups are all done. We don't want to spend time on that, but we now want to make a brand new design here. And so I'm going to start in semiconductor item management. I'm going to create a new line, call it Ether 4. I'm going to say I want to connect it to a repository. That's our semi repo. This is a level of detail we'll cover later. This is what connects items to repositories, whether they're internal or external. So we have created that item. If I was to come down here and grab this information and copy that, I could use Swiss create and create a workspace that would only have this data in it, but that's not what we want. But my next step here is to say, okay, this little button here is connection to our repository. And this little magic button here is how we get sharing page to determine what is the access into this thing. But let's now set up the access. The leader is going to be people in this group. I'm going to use, we'll talk in the deep dive why we pick different levels here, but the first 3 all have write access in the repository. These will be my designers. This last one, a viewer, only has read access into the repository. Come on. It's hard to type with all these people looking over my shoulder. But remember, use somewhere else. We're going to make sure that we add that as well. So now we've taken care of the access control for the data itself. Now we're going to set up an environment to work on this thing on. So we're in our new app here, and I'm going to create.
Hold on.
Yep,
Hold on.
yes.
Don't you have to create your structure?
Oh, Thank you, my straight.
Sorry,
No, no, that's great.
just didn't
Okay.
want you to miss anything.
No, that's great. Let's go. Let's go. Yeah, because then we'd only get an empty thing,
Right.
nothing else.
Yeah, right.
So now that we're in the semiconductor, here is where we can see the content of the repository. As you can see, there's nothing in it yet. That's the top level of the directory structure that's empty. But this is how we manage structure. This is where we've taken logical product definition functionality and embedded it into semiconductor item management so that we can now from within here pick this item. Come on. And insert existing references to other, that basically says other items. The other items that I want to include here is, well, we want one of those things. We want that release thing. We want that release thing. What else do we want? We want that release thing. So we'll just hook all those things up. And of course, if I expanded these guys out, we can see that they're also using the same technologies. We mentioned that before. So, but thank you, Ron. So now we're done with the design data management part of it. So we build a workspace. We'll get an empty one of these where we do, but we'll also get all of this data in the same workspace because the design tools need to see all that stuff. So now we'll set up an environment. We'll create a new one. I'm going to call it the same thing. And I'm going to, you know what? I forgot one thing back here.
Oh, that's right.
Yeah, notice that when I created this thing, this is configurable somewhere, but by default, if I create a new thing, we get this revision A, and that's not meaningful to most people. I usually, because I'm, trying to go probably faster than I should here, I usually say I don't want it to be A. We're actually going to be working towards our first release, so I really want to be working on R1. So I just inherited everything that's there. I don't need this A anymore, so I'll just get rid of that. I think once we set this thing up that we want it to be that when a user starts up, they'll start with whatever revision string that company wants to start with. So now we're working on R1. Now we'll come back over here. We're going to create our Ether4. I use the same name, same revision, and now we're going to get into some of the detail here. I'm going to copy stuff from my other show here, and let me just get that. Because if I tried to type this stuff in front of you, it would be a real mess.
So what Peter's going to be doing is pasting in a design area path, but the path will be using environment variables that this application has defined and knows about. And those variables will be filled in on the client side when these design areas get created.
Correct. Oops.
That's the wrong path.
That's definitely the wrong path. So I'm on another screen here.
Now that looks better.
That's a path. So to your question, Bill, this is using environment variables. This one here is the one's going to be set up at each design center and say, where do you want to put these things? Everything else here are internal variables that tell us, well, we want to under there, we want to put the design, what revision we're working on. Then we have a direct called users. Everybody gets their own user space and they get a directory for the responsibility they're working on, and then they get their actual area. So we'll talk about all of that stuff in December. And the other thing that we want to tell it here is where is our share cache directory? So we'll do that. Okay, now that we have this response to this environment put together, we want to tell it, well, what is the design we're going to work on? So we need to attach a data item to it. And here we're going to attach our in-work logical item. That's our revision control piece. So we'll attach that guy. Okay. And now we're going to go finish up this stuff. We're going to open this thing up. And over here, you see design responsibilities. And I'm going to create one. I'm going to call it design. So we have this. So I'm going to pick that thing. And down here, remember I said we have this have this item that has data in it associated with the design environment, scripts and other things in it that I'm not going to cover the detail of, but we want that in every workspace in addition to the design data management. So I'm going to say, what do you want to put in there as well? And we want this mixed signal design environment. We want that in the workspace. So we'll stick that in there. We're also going to determine, well, who can make one of these workspaces? So we'll come over here and look at our groups, and we want our
Hey,
designers.
Peter.
Yep.
Sorry, Rado speaking right now.
Yeah.
Make sure, normally when I create that, I make sure that I use the right version of the mixed signal environment. In my case, that's also R1.
Yeah.
I
Yes.
think you picked up version A, so I don't know if that's
Oh, but in
that's
that
intended.
case, that brings up an interesting thing. That environment is something that only had to be done by a methodologist once. So I got everything working as a methodologist, but then I needed to revision control that stuff. So I just created an item. I never assigned any responsibilities or anything, or I never assigned anything to it, even in the repository, because I was the owner. And then I used Swiss to create a workspace. I checked my stuff into it and I was done with it. And it is in fact called A. So I do
Gotcha.
have
All right.
the right one. But that points out that if you're not working on collaboration with a big team, you don't need what we're seeing here. All you need is a repository and a client-side workspace. That's all I use to do that mixed signal stuff. Now, having done that, we're going to say, who can work on this thing? Well, the designers and the leader, those are the people that could build a workspace of this ability. And those guys are going to, what tools are they going to use? Well, these designers, they're going to use Cadence. And I'll show you this when we get to it, but they're also going to be able to start some Unix shells as well, because a lot of designers are completely command line based. A lot of designers never use a graphical tool. Okay, so we've actually done everything we need to do here. So let me in here as a designer. So I'm going to come over here as a different person here that's doing design. I'm in a different browser, and I just got in here. All I really need to know is I want to know what my responsibility is. All I can do is copy a link for that, and I'm ready to go. Oh, no. I'm way ahead of myself here. Sorry. I'm worried about time. I should stop worrying about that.
I'll worry about that, Peter, for you.
Okay, very good. Get back to where. So where are we right now? Well, all we have done is set up an environment and we have an empty repository. Nobody can work on that until me as the design leader put some data in it. And then everybody else can work on it. Okay, so I am going to go over. Now I am logged into the using a virtual network connection into the Waltham data center, which I think has now moved to Marlborough, but this is the Unix network where So I am sitting on a machine called Wall, VRH. This is sitting on a machine on a network. I'm logged in as myself. I'm Peter. I am sitting in my home directory. If I said, do I have any Cadence? Could I run Cadence if I wanted to? I could say which Virtuoso. And say, no, that's not set up. Either I got to set it up myself to use it, or somebody else has to do it. And that's what this is all about. It's all going to be done for me. What I want to do is simply SDE create, give it the URL of that responsibility. So that just copied it. I'll paste it here. It asks who I am. That's my trigram. I'm going to use a particular collab space here, and off we go. So this is pulling everything that we want into that workspace, including the empty ether design. So if I now do a SDE list, design areas do I have? Well, I've got a bunch of other ones, but I'm going to go to the one I just made, which is this ether 4. So I'm going to go to this works. If we look in there, we see we have data. If I look more closely, I can see that these three IPs, the analog control bias port and Tech 090, they're not in my workspace. All the data for those, the directories of that data, they're sitting off in these caches somewhere. So they're not taking any extra space. Everybody shares a single copy of all of these things. That's part of the efficiency part. This
Is
is,
that like a module cache link?
that's exactly what that is,
Okay.
except it's an item cache.
Okay.
This I haven't released, so this is not cached yet, but this is where my design scripts stuff end up here. But this is if I go into this directory, that's my design directory. I want to show you up here before I do that. You'll notice there's also a directory here called .sws. That is our metadata, and that it keeps track of what data is in here. So if you go to update it, it knows what to go get. It also in there is all of the environment tool scripts and everything else that are embedded in here that make that stuff work. If I come into the ether itself and I look in there, it is of course an empty directory, but note that there is something in there. We're going to talk about this in detail in December, but the semiconductor repository was patterned after Git. And Git uses a local repository. This is like a Git local repository, but it's much more efficient than that is. But that's why it's there. This is what ties this directory to the repository service itself on the platform. But what we want to do is most designs do not start from scratch. You have something to get started with. I have some data sitting over in this directory, so I'm going to copy from here. I'm going to copy everything in there to my current directory. I'm going to do wrong there. Oh,
Forgot the recursive.
Forgot the dash R. This, by the way, is a data set that I got from Cadence. So it's actually real semiconductor design data. It is, but it's for a, what happened? What happened? Oh, Yes. Now, okay, this is just the way Unix works. Let me do this from, so I stop.
So we're getting close here, I think, right, Peter? Probably another
Yeah.
5 minutes or so.
Yes.
Okay.
Oh, come on. Oh, what?
Was it
Find
IP.lib, right?
Yeah, let me just find it. Okay, let me copy this from my PowerPoint so I stop fumbling around typing in front of this crowd. Oops, I just messed up something over there. One more thing and then we'll be done. So we now have, we have all the data we want in here. Because I'm in a workspace, if I go back to the top of it, this is my work. If I do an SDE run at this point, it says, well, what do you want to run? This is where we start tying the environment in. And if I run Cadence, tools you want to run? Well, this Cadence installation has a lot of tools in it, but I'm only using one called Virtuoso, which is why there's only one here. And I'm going to say, go ahead and start that tool. So the user doesn't have to worry about having the right stuff. It's already done for him. This is a starting point. We come into the library manager here. Now we can see we have our PDK library, we have our standard cell library, we have our bias part, analog control. This is the design we're working on. If I come over to here and I look at a particular cell, I'll see that all of its views are unmanaged, right? And if I was to click here, we can see that these asterisk things are the semiconductor engineer commands embedded into Cadence. Now I could check in data from here, but I don't want to check in. I don't want to check in just my library. I also want to check in the environment as necessary for it. So I'm not going to do it from inside of here. I just wanted to show you that if I looked at this point, the data is unmanaged. So if I'm back here in Ether and I do now I'm running they'll say, what is the revision control status of this workspace? Well, it tells me I got all this unmanaged stuff. So we're simply going to check in. Everything that's here. We'll go do that. So this is going off to wherever that, oops, I got to do one thing here. This is because I keep changing users, I got to do something. This is keeping track of my credentials and things like that. But I switch users all the time, and normal users would never ever do that in an environment, but I'm simulating multiple people. Oops. That looks better. This-
All those people staring over your shoulder,
I
Peter.
know, it's like there's 100 people watching me. Okay. You'll notice that once I did that, once I authenticated, that it actually pushed 95 megabytes of data up into the repository. But this is stuff we'll cover later. But it at first it compressed it down to 1/3 its a size to get it over there. But that data is now checked in. And if we were now to come back, and I didn't have to have closed that, but let me refresh this guy. Where's the right refresh view? You notice that this data is now checked in, and these are the first 8 characters of the commit IDs, if you will, for that data. So that's completely up and running now. Now our designers can go to work on this team, and I'll show you one of those guys.
Can
That
I
is
ask a
gonna-
quick question? Is
Absolutely.
that username and password gonna have to be entered each time you do that, or is there a way to?
No, that is that is what was stored in that file that I just removed. So
Oh, okay.
that's good for a period of time. But because I was doing other things in a different period of
So it has
time,
to be re-authenticated? Is it matched off of anything else? Like, is that
some
period of time matched to like, I don't know, a setting or
Mahesh can
Well,
answer that question.
LDAP or I don't know.
it's defined by the 3D experience, 3D passport settings. It might be only a couple hours or it might be a week, something like that, but that's not under control by our applications
Right.
Okay.
as far as the 3D experience credentials.
So now we're going to come in as one of my designers, Kristen Whitney. She doesn't need to know much about the platform stuff at this point in time. She can simply look at what roles you have. Well, she gets the connected semiconductor engineer role, and all she needs to do is open up this role. Because I had assigned her a responsibility to work on this project, she simply can come over here to my design responsibilities and finds that she's been working on other things, but notice that she's now assigned to work on this Ether 4. Okay. And she's in a role called design. So she's simply, okay, I want that. Well, we're going to go back over to the client side. I'm going to a different window. Over here, I'm logged in as Kristen, but I'm using a bunch of test accounts. So Kristen is Tron4 in Unix. Tron4 is logged in, but one thing to do, if I did which virtuoso, oh, look at, Ron already has some version of Cadence in his environment for some reason, but it doesn't matter. But this is not the one we want to use, nor it probably doesn't have semiconductor engineer embedded in it or anything else. It's just showing you that we're going to take out of the user's hands all of that necessity, and we're just going to paste the thing that I just copied. What did I do there? Oh,
No, you don't have SDE, Peter. What's
yes,
the
sir.
environment for Tron4 for where the SDE client's found?
Oh, yeah, you're correct. Thank you. Yeah, this was all set up before I had to reboot my machine at the beginning of this meeting. To tie all these other people in, I'm going to just, I had this all done previously. Now we have Again, just to make sure that I have the right one, which was that one.
Are there plans to be able to, oh, I don't know how we would do it, but you know, for
Yes,
users to
yes.
know the URL without having to.
Well, there's work we're gonna be going on, that's going on right now. We're in design of basically how to be able to launch all these commands from 3D Experience. So you won't have to be copy and pasting URLs and that kind of stuff. You're gonna
So
be
a
able to
user would
create
log
design.
into the user, or the admin would create.
No, you would be just like Peter did to go log into semi-item management as the designer and go grab that URL to create a design area.
Uh-huh.
They'll be able to basically say, go create me my design area from the application, from the web app, and it will be materialized on the Linux host. And then you'll be able to go launch the tool from the web app.
So is
So
there
is
also
it gonna be
a
more
way
like
to
these
have all
developments?
of the workspaces, you know, like how we have in, that's one of the advantages to developments right now in Legacy Design Sync, is for admins to know where
Oh,
all
yeah.
the spaces are.
It will all be registered. Yep.
We're
Okay.
going to show you that.
Okay.
Okay, so I'm logging in as Kristen Whitney. I have a credential. And what happened over here? Sure.
Permissions on the Unix workspace.
Yeah, I was gonna ask about that. How does the Unix logins relate to the 3DS logins, and how does this work as far as the
Well,
repositories and stuff?
they don't. They
Oh,
can
well, that should be interesting.
No, if a company can set those things up so they all match up, that's fine. A lot of companies don't. For instance, our Unix passwords are not our trigrams, and this is how we work. I'm Peter in Unix, but I'm good.
Right, but most of
in the
our
platform.
customers use LDAP and they do match everywhere, right?
Mm-hmm.
So I mean, and that's how they determine permissions, is by the people's logins and stuff. So I see an issue with this. I don't know.
Yeah, they're going to
Well,
want to be able to use that.
Well, when we get into the deep dive in December, that we can explore these questions in some more depth.
Okay.
But Peter, if you can't wrap this up or get this working, let's just move on, but see if you can see what you can do.
Okay, well, what I will do is I'll come back over to here and refresh this page.
Yeah. This is where the admin or project lead would be, and this is in this design environment management app. And Peter's going to show, I think, that workspace that got, or that design area that got created is right there now registered.
That is the one I registered. Let me go back now to this. I was going to go in there as a verification engineer, build a workspace, and then launch a tool. But notice in this case, it launches Custom Designer, not Cadence, but we don't see any revision control stuff in here at all.
But that's coming as well.
That's right. So a designer, as I said, simply goes in and to semiconductor item management, picks something what they want to work on, creates a workspace, and then it'll keep track of where all those workspaces are for you. On the SDEM side over here, if we had created a bunch, why am I getting stuck in that again? If we had 50 workspaces for various responsibilities here, they'd all be seen right here. Each user would only see their own responsibilities. So what I'm going to do is I'm going to stop there. And what I will say is one approach to doing this would have been to make a video to make it nice and smooth. But the reason I wanted to do it live is to show you that it is live stuff. There's actually no vaporware going on at all, or no smoke and mirrors. This stuff really is up and running, and I will stop there and answer any questions there might be.
Hey, Peter, very nice job, and this is super exciting. I will follow up with you and trying to figure out how this stacks competitively, and also trying to work on the ROI side, and it's like, how's this going to be different from what they have today with the existing environments. But yeah, very nicely done, and the entire R&D team. So hats off. Finally,
I would say from a competitive situation, this environment management stuff, the only competitor is our legacy tools. It's unknown. We don't believe that any competitors are actually providing this particular capability. They're all doing the data management part, but not this environment part.
Hey, Peter, will we have access to this platform for being able to go through and set up repositories and things like that, or will support to set up their own e-for-alls and stuff?
That's true, Peter. This is your own private e-for-all, isn't it?
This is my own private e-for-all, but anybody would like to use it and play with it, I'd be glad to go in and add you into some appropriate groups.
I think it would be appropriate to create a North American high-tech or maybe a worldwide high-tech public cloud where we can all work with this together.
This is in 25x GA in production, right? So be available to everyone.
Yeah, but I think maybe, I don't know if Bijan's on the call, but this might be something, Bill, that getting something built up in the experience center for a lot of people to utilize. I don't know if Bill's still on.
Yeah, so the data, none of this data exists or any of this exists in any experience center servers or public cloud high-tech environments yet.
Yeah, no, I don't think it does.
Well, and from a support perspective, we don't use the experience center, so we would need to be able to connect to the platform and then, use repositories that we set up on a Unix machine using data on like the Waltham network kind of thing. Or if we use our Windows laptop for some connector stuff.
Well, why don't we just,
but for Cadence stuff, we have to be on Unix. I mean, we have to, so,
yes, you do.
right? We have to be able to connect.
Matter of fact, for any of the semiconductor repo clients, they're only supported on Linux at this point.
Okay.
But then how would we also get Cadence licenses on a cloud instance that we all share too? That's going to be a challenge too, right?
Well, the Cadence tools are not licensed by our cloud. Those are going to be licensed on the Linux network at a design center. Okay, that's a customer issue, not our issue.
So Marcia and Elaine, why don't you get with me?
I'm saying for us to be able to demo this full flow that Peter's showing.
Because you all have logins on Waltham, which means you can do everything that I've already done here. You don't need Cadence or anything. It's all there already. I just need to add you as in some user groups on this environment, and you're ready to go.
Perfect. And if you could send this the URL to your server.
Yeah, maybe Peter, you might want to set up a separate call just with maybe
let's do that.
A few folks like Marcia and Janet and Elaine.
Anybody that would be interested in playing with this, please email me, and then we'll set up a separate group and we'll get you all added to this machine. So the reason I did this on an e-for-all, by the way, is because our cloud instances are temporary, and sometimes they only last a couple of days, and I did not want to set this thing up, start the KT, and have the thing had disappeared on me. So
he's talking about the R&D cloud.
The R&D clouds, yes.
Yeah, not the production.
Which is the only, that's the one that we use. But please, if you want to play with this, email me. I'll set up another meeting and we'll get everybody up and running on it using this design.
Okay, we'll assume I want to be, and
Yeah,
Okay.
I would too.
and probably Kuan for the
Yeah, me too.
time he has.
Me too.
But because Kuan's retiring in May, but
Oh,
yeah, so
Okay. Well, thank you, Peter, for your effort here in putting this together. And as we said, the deep dive sessions will be the week after, or the first week of December, and I will be posting into the XCC swim community,
Global community. It's a global community. XCC
the
global community.
yeah, the XCC global community. The details for those deep dive sessions. Okay. And we'll record all that, and we'll post this recording up into that same swim community, recording of today's call. And any other future questions, feel free to reach out to Peter, reach out to myself. We'll be happy to answer. There's a lot more coming as well. Most of our emphasis is on expanding this semiconductor engineer role. So we're going to be having quite a bit more stuff coming in 25x FD01, FD02, FD03. Going to see a lot more functionality related to semi-engineer.
and actually, really quick, I meant to show. If I go to our top level design here and open this, this is the schematic side of it. Where is it? This is what the design looks like here, which is what we're working on. But this piece here and this piece here are from other design teams. That's how all this design reuse stuff works. These are all in different directories on disk in the workspaces, but it's assembled in the Cadence database into this environment here. So there is there's a difference between what the design looks like and what the data on disk looks like. They're very, very different. Okay. Well, thank you, everybody.
All right, we'll wrap up here. Thank you, everyone.
thank you.
See ya, and have a good Thanksgiving for the U.S. folks, and hopefully we'll see most of you back in December for the deep dives.
Yep. Thank you.
Thank you.